Okay, so let's talk about kinematics a little bit. Kinematics is a way of determining different variables, and I'll show you the equations right here. They include final velocity, initial velocity, distance, time, and acceleration. And so I've listed the 5 basic equations. And these are sort of more European units, and it's kind of tied to the International Baccalaureate program that I'm teaching. So I'm showing you here on the side which one of these means. V would be your velocity final, U is your velocity initial, S is your displacement, T is time, acceleration, or A is acceleration, which I just want to point out sometimes can also be written as G for gravity, although these are all horizontal problems, so we won't be dealing with gravity this time. Now, normally what I will tell students is that you want to go through, all these problems will have 3 variables that you know are given, and 1 that you don't know. And so you want to find the 3 variables you're given, figure out what you want, and then also maybe point out which one you're missing, because then you can just go through here. I have off to the side which one each of these equations is missing. So in this case, it's missing distance. So if you do not have a distance component to your problem, then you would use this equation right here. All right, so let's just dive right in and solve a few of these problems. I'm going to go through 4 of them. They should give us an example of each type of problem that we have. And so always with these problems, I want to start out by writing down my 3 variables that I have. So my variable 1, my variable 2, my variable 3, and then what do I want? What is the question asking me for? And then I could also say, what am I missing? You know, as in what's not there, just to check what I have. All right, so a car initially traveling with a speed of 16 meters per second. So that is, this is U, and it equals 16 meters per second. Accelerates uniformly to a speed of 20 meters per second. So that is my V, as in my final velocity, which is 20 meters per second, over a distance of 36 meters. So that is S for distance, and it is 36 meters. What is the magnitude of the car's acceleration? And so in this case, I'm being asked for acceleration, and that's my question mark. Okay, what am I missing though? Okay, so what I'm missing is time. And so when I go through and I grab my kinematics equations and I look here, I just need to find the one that's missing time. I can use V squared equals U squared plus 2AS. So that's the only one that's missing time. And so let's write that up right here. V squared equals U squared plus 2 times acceleration times S. It's asking me for acceleration, so I'm going to go ahead and just kind of manipulate this so that the acceleration is on one side of the equal sign and everything else is on the other. So let's say that we have V squared, and I'm going to subtract out, let's get rid of that U squared, the U squared from both sides, and then I'm going to divide that by, since I want acceleration, 2 times S, okay? And let's put that into some sort of numbers. V squared, I have 20 squared minus U squared, which is 16 squared, divided by 2 times 36 meters. And that is going to equal, now let me figure out what it's going to equal. 20 squared minus 16 squared divided by 72 is going to give me an answer of 2.0 meters per second squared. Okay. Okay. The speed of an object undergoing constant acceleration increases from 8 meters per second to 16 meters per second in 10 seconds. How far does the object travel during the 10 seconds? So let's start this again with my first variable, my second variable, my third variable. What do I want? What am I missing? Okay, so we'll start with 8 meters per second. It increases from 8 meters per second, so that is U is equal to 8 meters per second, to 16 meters per second, so that's V, my final velocity, of 16 meters per second. And then it takes 10 seconds, so that's time is equal to 10 seconds. How far does the object travel? That's S, and the question mark. And then what is missing? Well, what's missing is acceleration. Okay, and so when we go to look at this, it's this equation right here where distance is equal to initial velocity plus final velocity divided by 2 times time. So let's put that equation in. S is equal to U plus V divided by 2 times T. Okay, so let's see. I'm going to say, I'm going to move over to this side here because I have a little more room. I'm going to, since I'm looking for S, that works out. My U is 8 meters per second. And I'm going to add 16 meters per second. I'm going to divide that by 2, and I'm going to multiply the whole thing by my time, which is 10 seconds. Okay, so I have what, 24, if I add those two together, divided by 2 times 10 gives me an answer of 120 meters. Okay, piece of cake. Love kinematics problems. They seem complicated, but then we have these handy dandy kinematics equations there that we can use to solve them all, and makes us look like we know what we're doing, which is good. Okay, got 2 more here. A car initially traveling east with a speed of 5 meters per second is accelerated uniformly at 2 meters per second squared east for 10 seconds along a straight line. During this 10-second interval, the car travels a distance of, we don't know. So here we go. We got V1. Let me just move this up just a little bit so I can make sure I get that. And I have V2, and I have V3, and then my want, and then question mark, what do we not have? So let's see what we can go through here. It initially traveling east with a speed of 5 meters per second, so that means I have a U equal to 5 meters per second. Is accelerated at 2 meters per second squared, so I have acceleration equals 2 meters per second squared. East for 10 seconds, so I have time is equal to 10 seconds. During this time interval, the car travels a total distance of S equals, we don't know, and that means I am missing final velocity. Okay, so my equations tell me that if I'm missing final velocity, I'm going to use S is equal to UT plus 1/2 AT squared. So let's write that down. S is equal to U times T plus 1/2 acceleration times time squared. We'll start punching in some numbers. S is on the left side of the equal sign, which makes our life a little bit easier. Our U is 5 meters per second. Our time is 10 seconds. Plus 1/2, 2 meters per second squared times 10 seconds squared. Okay. So when we go through here to do the math, we could probably just do this in our head almost. We got 10 squared, so that's 100, times 2, times 1/2 of 2, so this is equal to 1, so this is just 100, plus 5 times 10, so that's 50, so this is going to equal 150 meters. Okay, last one. Let's see what we have here. During a 5-second interval, an object's velocity changes from 25 meters per second east to 15 meters per second east. Determine the magnitude and the direction of the object's acceleration. So first we're going to determine the actual calculation, come up with numbers, and then we'll discuss magnitude and direction. So remember that magnitude is the number that we're looking for, essentially, without paying attention to direction. And then the direction is going to be, with acceleration, will be told to us by the negative or positive sign that is attributed to it. So here we go. V1, my first variable, V2, my second variable, V3, and then what do I want, and what am I missing? Okay, so what do we have? Doing a 5-second interval. So first thing, I have time equal to 5 seconds. An object's velocity changes from 25 meters per second, so I have a u equal to 25 meters per second, to 15 meters per second, so I have a final velocity of 15 meters per second, and determine the magnitude and direction of the object's acceleration. Acceleration is what I want. Am I missing s? I don't have any distance component in here. What is missing s is that very top one. Velocity is equal to u plus at. So that's a simple one. So we're going to do v is equal to u plus at. And so let's see, make sure I have enough room on here. Let's try it over here. I'll put it right in this here. So I want acceleration, so let's isolate acceleration. In fact, I can just do that right here. We're going to do v minus u divided by t should give me acceleration. So I'll put that over here where I have v of 15 meters per second minus u, which is the 25 meters per second, and then we will divide time, which is 5, and then we'll see what kind of a number we get here. 15 minus 25 divided by 15 minus 25 divided by 5 is -2, equals -2 meters per second squared. Okay, so that's our acceleration. We're slowing down there, but this is also telling us that the acceleration is going in the opposite direction that it was initially traveling. So if you're going along at 25 meters per second in this direction, and then you slow down, it means the acceleration is actually going opposite of the direction that you're traveling. Okay, so that's why that negative sign is showing up. It's true, it's deaccelerating, but it also means that the acceleration is pushing in that direction against the velocity that you have. So the first thing I can say is that the direction, because I have that negative sign, is west, for a couple of reasons. First of all, because it's the opposite of the direction it was going, but also we tend to use east as being positive and west as being negative. And then the other thing, the magnitude, is just 2 meters per second squared, right? Because that doesn't pay attention to distance. So there's your answer.